Hi, I'm the PC expert amateur, and I've got a question. To AIO or not to AIO? That is the question. Before I start, I want to thank Lawrence Abrams, aka Grinler, the owner of bleepingcomputer.com, for hosting my text-based work, and the volunteers who provided suggestions and corrections for this video. Old Sod, Porthos, PK Shadow, and please support BC, which has helped the world for 2 decades now. So let's start out with the finish. Too long, didn't read, or didn't watch. What's the conclusion? I'm so overwhelmed by so much information. To boil everything down into a nutshell, unless you're regularly hitting really high temperatures, we'll say 90 degrees Celsius or greater, although it really varies depending on the CPU, don't get an AIO. Try one of the top tier air coolers. Some of them are very inexpensive and do a great job. So now that 95% of the viewers have dropped off, we can have a nice fireside chat here, except I don't have a fireplace. I do have these lovely lengths of batik from Indonesia, which I brought with me when I had to flee the country after my wife died. And I thought these would be a nicer view than seeing the clutter over here of the tech stuff that I have and then my bed behind me. And then I don't have to see messages from people saying, "You should clean up your room, it's a disaster." Seriously, folks, if you think that's a disaster, you have got a problem with OCD. Let's start with what is a cooler? It is any system that is designed to carry the heat away from your CPU, GPU, SSD, or other very hot part to the heatsink. A heatsink can be many things, even a radiator from a vehicle or cleverly cut up aluminum cans. Simple, relatively low heat devices use a heatsink with no fan. And for now, we'll be focusing on CPUs. There are 3 kinds of coolers: air, AIO, and custom loop. Now I can show you examples of air and AIO, but I can't show you custom loop because I don't have one. If I were giving out awards for a very attractive packaging for an air cooler, I would choose this one. It's probably the best looking packaging I've seen thus far out of the, I don't know, I've got 20, 30 air coolers out there. How many air coolers do I actually have? I'm not even sure. Let me look. Let's see. Oh, I've got about 27, unless I forgot to write one of them into my inventory list. So an air cooler, and I'll show you more about this later on. And then the water cooler. Now, this is arguably one of the currently the best water coolers or pre-built water coolers, AIOs, on the market right now. The Deepcool LS720 SE. There's also one without the SE, and they come in white and black, and they come with and without LEDs. I just happened to get this on sale for under $100, and unfortunately the one that didn't have LEDs, which is what I really wanted, was rather more expensive, so I went with the cheap option. But still, this is a highly regarded choice. So, within the air category, there is a subcategory called a passive cooler. These don't use a fan, pump, or any moving parts, hence the name passive, and as a result are not suitable for high performance, high heat PCs because they rely on the convection current produced by air being moved by a difference in temperature. The higher the temperature, the faster the air moves. But personal computers, aka PCs, which is any computer designed for home use, no matter who makes it, even Apple, yes, even Apple, don't produce enough heat to really do much. Thus, that current can easily be overthrown by fans. I mean the air current. They are fine, however, for the average casual user if you've got a big enough case. because, yeah, they're not small. I mean, the old school ones from the days when CPUs didn't actually get very hot were small. I mean, really small. Maybe the size of maybe a third of the size of a phone. Oh, those were the days when you could have a box with a couple holes cut in it, and that would be enough for you to have a computer that didn't overheat. Now, no. Heat transfers, as with all coolers, from the CPU, most often with the help of a thermal interface material, or TIM, to the contact or cold plate of the cooler. The heat moves from there to a heatsink, most often by tubes. Those could be rubber tubes, those could be metal tubes, or other kinds of tubes. Except for passive coolers, one or more fans blow through the heatsink, neutralizing the heat. Now, I know you're probably saying, I don't get it, Glenn. What does that mean? Well, don't worry. The PC Expert Amateur is here, and I will show you examples. A cooler is held firmly against the CPU or other component by one of a variety of mounting or securing devices. When choosing a cooler, it is a good idea to find one that has a TDP that is higher than the TDP of the component you need to cool. If you plan to use it in future computers, pay attention to the trend in which CPU socket is being used and choose a cooler that has an even higher TDP. Note, a cooler cannot lower the temperature of the CPU to less than the temperature of the room, unless, of course, you're going to introduce things that can do that, like ice or liquid nitrogen or dry ice or something like that. And in that case, you have to take special precautions. But this is not a class on custom loops, so I will not explain further, especially since it's not my area that I know enough about to feel comfortable to share with you. Question: how can heat possibly be neutralized? Well, as the air flows through, the heat transfers into the air and the temperature changes to a point between the heat of the radiant energy and the coolness of the air. As the ambient temperature rises, it can understandably have less of an impact on the temperature of the resulting mixture. This is demonstrated by measuring the change in temperature in the rad and the air exiting it. The water that's leaving the radiator will have a lower temperature than the heated water that entered the rad too. People often worry that having a front-mounted rad is the worst option. I used to think that, with fans intaking air, because the heat emitting from the rad would all be pushed into the case, when in actuality, until a particular, I can speak, really I can, no, just not well, thermal point is reached, the air going in will neither be as cold as the room temperature, often called ambient, nor as hot as the loop water. So it's going to be somewhere in between. What is thermal interfaced? I lied, I can't speak. What is thermal interface material, or TIM? These go by several different names. In general, thermal compounds, and more specifically, paste, grease, liquid, metal, pad, and sheet. The thermal transfer potential, how well it lets heat move through it, of a modern TIM, that's the, TIM, TIM, sorry, Timothy, from best to worst, is usually within 5 degrees Celsius, with many being within 1 degree Celsius or less of each other. Each type has pros and cons that come with it, but the most important thing to consider is how well it transfers heat, which is measured in watts per millikelvins, whether it is electrically conductive, liquid metals and sheets generally are, or insulative, most of the rest, and whether it might cause damage to nearby parts, liquid metal contains gallium, which can melt aluminum. Other considerations include a grease or paste's viscosity, which determines how likely temperature fluctuations that result in the warping of the CPU's top, or IHS, are to cause the paste or grease to slowly be pumped out. I know that sounds impossible when you have two pieces of metal against each other, but as one piece of metal is warped by heat and pressure that's uneven, that does actually happen. As well as a pad's thickness and how well a TIM ages. Although some of the best products are very expensive, there are also inexpensive TIMs available. In theory, a sheet can last forever. Some pads are easy to transfer, and a phase change compound, it changes its state of matter from a solid to a liquid, for example, tends to last longer than most other types of TIMs, but requires being burned in by exposure to a high temperature for an extended period of time, after which it performs much better than many other TIMs. Now, I know you guys are just really, really curious what I mean by paste and grease and liquid metal and pad and sheet. Well, paste and grease are very similar to each other, although grease tends to be greasier and less viscous or less thick. Paste, imagine like toothpaste, but not necessarily as thick as some of the toothpastes that are out there. Let's take a look at some of the choices. I only have 1 or 2 or 3 dozen of the greases and pastes, but they usually come in a package like this one. And they come in various sizes, and sometimes they come with accessories like this spatula for applying the TIM onto the top of the CPU, and this alcohol for cleaning old TIM off of the CPU. Now, I would show you some, but I don't want to waste it. And so just imagine it's got different thicknesses. Go buy a bunch of different little travel packages of toothpastes and then pump them out of the tube and see that they're not all the same in terms of thickness, and you'll have a pretty good idea about pastes and greases. You can also sometimes buy the pastes or greases in a round container, like a little jar, and it's usually made of plastic, and sometimes you can get a very large quantity, which is less expensive. But if you choose the wrong brand that doesn't have a good shelf life, you may end up having to throw away some of it unless you're using it very often. Now, this may look like a pad, but it is not actually a pad. Or sorry, a sheet. It's not a sheet. It is a pad. Pads, and I just have, a few dozen here, are generally pre-cut into a specific size and shape like that. And they have protective material on both sides, usually, to help keep them from being deformed or damaged until you can put them on the CPU or cold plate. Some of them are larger, so you can cut them up into smaller pieces, like that giant one that I showed you. And then there's liquid metal. Now, liquid metal, some of the pastes and greases do actually look kind of like liquid metal, but they aren't actually. They just have something in them that gives them this very metallic look to them. But that's just a trick of some sort or other. Then, finally, I don't have any liquid metal. I'm not really interested in playing with those at this point. But the sheets are the last thing I want to show you. Now, I'm going to show you this without touching it much, but that is a sheet, and it is extremely thin. Not the clear part, the gray part. And I don't know. Whoa, no, that is not what I wanted to do with my sheet. Oh, sheet. It's a good thing I licked my fingers beforehand. Just kidding. Just kidding. I licked my fingers after I had my snack, not before picking that up. But I got your attention, didn't I? So a sheet, the wonderful thing about a sheet is that if it's made right from graphene, it is very good at transferring heat, and you can reuse it many, many times. Now, pads you can also sometimes reuse depending on, there was a little glitch. I don't know if it, yes, we're going to carry on and pretend that that glitch didn't happen where the screen froze, and I have no idea why this never happened before. I'm really hoping that's not a bad sign for the graphics card, which, who knows? It could be the graphics card. It could be the motherboard. At this point in time, I'm just going to cross my fingers and hope it doesn't happen again. So pads sometimes can also be transferred depending on how viscous the material is, because pads are basically a thickened form of paste. And some of them, if you're careful, you can actually remove and put it on somewhere else. But most often those are pads that are not made from paste. They're made from a different kind of material that is reusable. But sheets are definitely reusable. The only challenge would be that, is the size of the sheet you've got going to work with the new CPU? If it's too big, then you can cut it just to a smaller size if you want. If it's too small, however, you're going to have to get another one or two sheets, maybe cut them up and surround it all, but they're also going to be very expensive because they last pretty much forever. All right. So now you've gotten a little bit of an idea of these things. Now, when I was talking about phase change compounds needing to be burned in, that's basically where you deliberately do something that heats up your CPU for an extended period of time to above a target temperature. Now, it could be 45 degrees Celsius, it could be 80 degrees Celsius, it could be 20 minutes, it could be an hour, it could be 5 hours. It just depends on the material that you're burning in. But once it's been burned in, it will perform even better than before. So, next on the list. Question: what is TDP? Now, I'm going to be a little bit imprecise here, but you'll get the point. For a cooler, TDP is thermal dissipation potential, which is how much of the heat produced by the CPU is transferred and radiated away to be neutralized by the ambient room temperature. And this is done by the cooler, obviously. The heat producing capacity of a component, like a CPU, is also called TDP, but refers to its maximum power. Both are measured in watts, but different manufacturers may measure their components' TDP differently, causing confusion for customers. So, for example, if you're talking about the difference between an Intel and an AMD CPU, the TDP that is reported is not the same for some reason that is beyond my mathematical understanding. Once you exceed the TDP of an air cooler, the liquid in the heat pipes becomes a gas as usual, but cannot reform into its liquid state because the excessive heat is preventing its recondensation. Now, I know you're thinking, there's liquid in an air cooler? Yes, but it's a very tiny amount. It turns into a gas, climbs up to the top, the heat gets dissipated by the heat sink, and then it reforms into a liquid and trickles down to the bottom over and over again. At this point, when it cannot recondense, the cooler is going to do a very poor job. This cannot happen in a water cooler, and if it does, that means your computer is on fire. I'm joking, but it's probably really, really bad if a water cooler can no longer function, unless you've bought a water cooler that's way too small for the CPU you've got, or conditions within your case promote a temperature that's way above what the cooler can handle. What I mean about this is that the total evaporation of the liquid cannot happen in a water cooler, but any cooler with a low enough TDP versus a component with a high TDP will eventually lose the fight and do a poor job. Does anybody have a spare tongue? Mine seems to not be working right today. To look at it another way, TDP is the maximum wattage at which the CPU will reach its maximum possible temperature. Question: what is an air cooler? This is a compact system that is mounted against the heat source, most commonly the CPU, and also a discrete GPU mounted on a PCB, which is an electronics board, and is called a graphics or video card, GC or VC, but erroneously and frequently called a GPU too. The GPU is the processor, the GC or VC is the entire unit, including the GPU mounted on the card and all the other little components mounted on it. Laptop air coolers are very flat and generally use a different type of fan, blower, aka centrifugal, which works similarly to a water mill but in reverse, and because of the limitations of size, cannot cool a laptop as well as a full-sized air cooler could. So just to be clear, this is a discrete graphics card. There's also on many CPUs from Intel and the newer AMD CPUs as well, an integrated graphics processing unit. It's part of it. You can't tell the difference from the rest of it unless you take it apart and examine it under a microscope or something similar, but most CPUs these days do have an integrated graphics processor, not graphics card, built into your CPU. So you don't actually, unless you're going to do something that's graphically intensive, like CAD, for example, or 3D rendering, you don't need a GPU or graphics card, I mean. So this is a graphics card, and inside here, right around here, the graphical processing unit is located. Now, as for the cooling in a laptop, you can see here we've got the heat pipe, and the heat pipe has been run over the top of this thing that's covering the CPU. And then if we go over here, we can see the blower style fan that spins like this, but instead of the air going this way or that way, it goes out this way, over here where the blower thing is. So it pushes the air out, and that whole thing allows the CPU within your laptop to be cooled, albeit not nearly as well as in a desktop computer. To put it another way, if you have a laptop and a desktop computer that have the exactly identical equipment in them, the laptop will perform not as well as the desktop because primarily it can't be cooled off as well. Let's see. Where was I? Ah, yes. Older air coolers had very small heat sinks with very thick fins and didn't necessarily have a fan. You can still see them in some devices that don't produce a lot of heat. An air cooler is one solid piece plus one or more fans, and I'm going to show you. Now, just as a point for anybody who's planning to assemble a computer, if you have an air cooler and the aluminum that's like this stuff here has not been painted over, please wear rubber gloves because the oil on your fingers will get onto the aluminum and over time will damage the aluminum. If you don't have gloves, you're going to have to make sure to clean the oil off of your cooler, which can be very problematic because you're dealing with fins. All right, so a cold plate, which is behind this piece of paper here, and oh, by the way, most coolers will come with either a plastic or paper covering over the cold plate to keep it clean because it's usually made of copper, and that also doesn't react well to not just your fingers touching it, but also to air. Because if you haven't noticed, copper can turn green when exposed to air for long enough. So that's the cold plate, and it's pressed against the CPU's IHS, which is the top layer of the CPU. The heat pipes, which you can see here This one has 4 heat pipes, which are hollow, contain a small amount of liquid, and are usually made of copper. Although you can't tell it because they've been painted. So these could be made of some other material. And the fins. Now it's kind of hard to see them on this unit, but let me just pull off this. And then you can see those are fins. Which they look a bit like a stack of closely spaced shelves. To be, really closely spaced shelves. You'd never be able to put a book in there, although perhaps maybe a comic book could be slid between them if it was a passive air cooler. Nowadays, most heat sinks are made of the pipes and 1 to 2 arrays called towers of thin parallel plates of aluminum or other metals. They're not all towers, though. Some of them are laid down flat and are very small and relatively ineffective compared to some of the alternatives. In passive air coolers, thus, you'd have the potential of storing things between the fins. Not that you should, because then it's not going to work as a heat sink anymore. Points of failure. Air coolers only have 2 common points of failure. 1, the thermal transfer compound, or TIM, which will dry up, pump out, degrade, and or otherwise fail. And the fans, which will eventually fail too. There are other points of failure, but they're extremely rare. So I'm not going to bother to mention them. I don't want people worrying about something that probably will never happen to anybody less than the millionth person, okay? These 2 weaknesses, the TIM and the fans, are also present in water coolers, which have several more, as we shall see. It is highly unlikely that you will experience other points of failure with an air cooler unless it's poorly made or you damage it. Just being repetitive here. The only other weakness in air coolers is the limit to their ability to dissipate heat versus a water cooler. The hottest temperatures require the largest coolers, and that means a larger case, and so on. An air cooler is more likely to overheat if you have a graphics card, especially if the latter blows air up into your air cooler, and your air cooler is oriented vertically such that the hot air exiting the graphics card, which would be down here, immediately goes directly into the fan at the bottom of the heatsink and into the fins and then out the other side. So you're not getting ambient air, you're not getting case air, you're getting heated air from the graphics card. Not all graphics cards blow air up, thankfully. And as far as I know, no graphics cards blow up. Yes. One other advantage of air coolers, along with lasting nearly forever, is that they can provide extra airflow over nearby components. A water cooler can only do this if it has a VRM fan, and that may not help other components. With either type, you can also configure other fans to cool those parts, no matter what type of cooler. Question: what is a water cooler? Well, we're going to be looking at the deep cool in a minute here. A water cooler is a system, also called a loop, that receives heat transferred from the CPU to the radiator, which is cooled by fans moving air through. There are 2 kinds of water coolers: AIO, aka pre-built or closed loop, and custom, aka bespoke or bespoke cooling loop. Now, for those of you who are not familiar with British English, bespoke is the same as custom. Water is a much better medium of transfer of heat than air and metal, and is far better for transporting the heat from the source to the radiator because it moves. But it has some risks that balance out the rewards. The loop starts with the cold plate, which is under here, which is firmly pressed against the hot plate or the die if the CPU has been delidded of the CPU, and is housed within the water block, which may be composed of 1 or more chambers that you can't see, as well as inlet and outlet ports for the liquid, which are right there. and may house the pump. The liquid's base is water, which is distilled and sterile and will include anti-corrosion, which it prevents corrosion that can occur when there are two or more types of metal exposed to the liquid, usually copper and aluminum, and biocidal, which prevent the buildup of fungus, bacteria, and other life forms, and can be a liquid or a solid like a strip of silver. Agents moves the heated liquid away from the cold plate via the tubes, which may be made of metal, glass, or plastic, hardline, or rubber, softline. One which takes the liquid away, and the other that returns the liquid to the block, hence a loop, and is pushed by a pump. Because convection current is not effective enough due to the relatively low heat of the liquid, the influence of gravity, and the positioning of the cooler's parts, to the radiator, where fans move air through it to neutralize some of the heat of the water. And since I foolishly ventured into getting AIOs that are 360s instead of more intelligent choice of 240s or 280s, which would have saved me a significant amount of money by now, I have 3 fans that came with this particular model. It may or may not have other parts, most of which you'll only see in a custom loop, such as water blocks for other hot components. There are a small number of AIOs that have those. Water flow, temperature, and pressure meters. Those are very rare in AIOs. Reservoirs, aka res, for extra liquid to replace that which is lost through evaporation and osmosis, air moving into the system through pores in the rubber tubes. And I don't know that there are any AIOs that have a reservoir, but it wouldn't surprise me if there are some. Drain and fill ports, because you need to sometimes drain and fill it to replace the bad liquid or dirty liquid or whatever. Or maybe something else is going on. LCD displays, which can show useful system info or useless images. They're not really necessary. It's just some bling, you know? LED lighting, which are even less useful. Because they are purely aesthetic unless they run off the same cable as the motors in the fans and the pumps, in which case they reduce the performance of those devices. And colorants, which provide a particular color, glittering, UV reactivity, and or viscosity to the liquid. Now, you'll notice I didn't show you a pump. Well, I can't show you a pump because, unsurprisingly, they are not exposed. There's a pump inside here. Sometimes you'll find pumps on the tubes, and sometimes you'll find a pump in the end or in the middle of the array of fans somewhere. Are you getting overwhelmed? Please do pause and come back to this when your head is exploding. Now, for water coolers, there are more points of failure, as I mentioned before. And in addition to the 2 points of an air cooler, water coolers, closed and custom, suffer from others, including, now for closed loops or AIOs or pre-builts, aside from hard-line tubing, all tubes are made of some type of rubber, which is porous. The more flexible, generally, the greater the porosity, and thus the faster air enters the loop. 2. Leaks after installation is complete for several reasons, but usually due to a failed gasket, damage to a tube, corrosion, or manufacturing defects, which are increasingly rare these days. 3. Pump failure, which is made worse by the fact that many motherboards do not have a failure alarm that goes off when it happens. And this is something that is the worst problem with a water cooler because it's inevitable. A pump is eventually going to fail, and because of the way most companies design the AIOs to be thrown away when something catastrophic happens, that's a big downside of water coolers. Corrosion of metals due to using more than one type of metal in the parts of the system that are exposed to the water or could accidentally be exposed if an internal gasket fails. Some manufacturers will lie to cover up that their product is mixed metal so that they can sell products that will fail and need replacing more often. Igor's lab recently did an expose of certain brands that do have mixed metal, even though they claim not to. Although he didn't test a large number of brands, so I hope that he'll continue with that. Clogging due to manufacturing debris and other particulates that the factory didn't remove prior to assembly. Gasp! Who'd have thunk that a manufacturer wouldn't clean out the loop before assembling it? Clogging due to the buildup of biofilm from biological activity in the loop because there is no biocidal agent in it to prevent the proliferation of bacteria, fungus, and other living organisms, which is usually because they don't have a sterile facility if it's not a problem of the biocidal agent. And the pump running dry due to air buildup with the pump being put in a place where the air will be trapped, the impeller freezing up, or overheating due to close proximity to the heat source. I'm going to try to get through this, which is only possible within the water block. Now, in custom loops, the list is a little bit longer. Hardline loops are very hard to configure correctly and install. It takes a lot of effort and time and expertise to know how to bend the lines correctly without crimping them, without breaking them, and it is a bit of an art, especially if you want it to look very interesting. Yeah, it's challenging. Leaks during testing the fitting of hard and soft tubes in a custom loop due to mistakes such as incorrect coupling, incompatible parts, missing, failed, decaying, or misseated gaskets, excessive pressure, etc., including errors made at the factory, which can result in damage to other parts or destroy the CPU or the whole PC. Yeah, big risks with custom loops. Leaks after installation is complete for the same reasons and with the same consequences. Most often, you are the one who installed it and you are the one who made a mistake. Pump failure, which is made worse by the fact that many motherboards do not have a failure alarm that goes off. Again, oh, what a surprise. Corrosion of metals due to using more than one type of metal in the parts of the system that are exposed to the water or could accidentally be exposed if an internal gasket fails. And again, some manufacturers will lie to cover up that their product is mixed metal so they can sell more products because they fail more often. Clogging due to manufacturing debris and other particulates that the factory didn't remove prior to assembly. Fairly unlikely except in the radiator when it comes to custom loops. Clogging due to the use of thick or viscous liquids, and that's usually something that's inflicted on the user by the user because you chose to buy a thick or viscous liquid. Clogging due to the use of glitter or colorants, as these will inevitably accumulate in low pressure locations or block high pressure ones, and also avoid food coloring and other organic dyes. They will become food for life forms in the water. Okay? So yeah, it's just, common sense. Slower movement of the liquid due to viscosity or thickness. Oil is more viscous than water. Clogging due to the buildup of biofilm from biological activity in the loop because there is no biocidal agent in it to prevent the proliferation of bacteria, fungus, and other living organisms. And the pump running dry due to air buildup with the pump being put in a place where the air will be trapped, the impeller freezing up, or overheating due to close proximity to the heat source, which is only possible within the water block. Question: that sounds scary. Should I really consider a water cooler? If you need one, yes. The chances of a problem aren't nearly as great as they used to be. Honestly, though, most people don't need a water cooler. But don't worry, the average lifespan of an unmaintainable water cooler is 5 to 7 years. If you maintain it properly, it can potentially last much longer or until the rubber starts decaying. Leaks in closed loops rarely occur anymore. You're most likely to experience problems due to air buildup, debris, biofilm corrosion, or the pump. Of these, they can be resolved through your own efforts if you can maintain the device. Wow, that was a weird noise. So a pre-built with maintenance possibilities is a great choice. Like this Deep Cool, because lovely Deep Cool put this port in here that bleeds off excess air in the system, and it can also be used to refill it. When looking for a cooler, always look for customer and reviewer reports of failure and performance results. And lest I forget, if you get a maintainable water cooler, it may come with a bottle of liquid to refill it once it gets too low. Now, again, I'm going to repeat this just for the sake of making sure you get this point. When looking for a cooler, air, customer water, it doesn't really matter. Always look for customer and reviewer reports of failures and performance results. Now, in the case of custom loops, you'll be looking for that information for the individual parts that you need, especially the pumps, the fans, the reservoirs, the water blocks. Now, I'd just like to pause for a moment here and ask for your help. It's not a big deal, but it would really help me if you could subscribe to my channel and click like on the videos that you think are good enough to deserve that, and put comments down below with suggestions and feedback, and even a thank you would be wonderful. As long as you're being civil, I'm happy to see comments. I will always try to respond. Sometimes I don't notice for months that there is a message to respond to because I forget to, because of the way YouTube arranges its comments and alerts you to new comments. Sometimes I don't know there's a message. I miss a message, and 3 months later or a year later, I'm like, oh, crap. So, also, if you think it's worth it, please tell your friends, your relatives, your neighbors, and random strangers at the mall. Oh, wait, people don't go to malls anymore, do they? Online, to please check out my channel, and hopefully it will be of use to them too. Thank you. What is an AIO? Also known as a closed loop or pre-built water cooler, AIO literally means all in one, which is a misleading term because it isn't specific to water coolers. In general, it applies to any device that is capable of performing multiple tasks that are somehow related to each other and thus complementary, such as a printer that also has a scanner and a fax machine and can copy documents too. In this case, however, we're talking about pre-built CPU water coolers. All AIO water coolers come with at least a water block, a radiator or rad, tubing, pump, which may be in the block, radiator, or on the tubing, fans, and mounting kit. Some may include other parts, such as a water block for another hot component like an SSD, and or a VRM fan, which is almost always built into the CPU block, extensions, splitters, and a fan or LED hub, which is to say a fan hub or controller or an LED hub or controller, or both, more often than not, with people going crazy over stupid lights. Oh, I mean highly valuable lights that speed up the quality and improve the quality of your devices. Yes, please excuse me, LED makers, for disparaging your products, which are valuable, I admit, but not in the context of things you look at for a week and then you forget exist. Many AIOs are not designed to be serviced by the customer and thus are often called e-waste as a disparaging reference to their potentially short lifespan, unlike air coolers, which can remain useful as long as you can use them on your next device. However, closed loops last quite a bit longer than they used to, but some people still comment based on the problems of yesteryear or yesterdecade. Pre-builts rarely have problems with leaks, but some have problems with clogs due to manufacturing debris, biofilm, or decayed material from the tubes later in the lifespan, Or the manufacturer may have secretly used two or more metals exposed inside the loop, leading to corrosion, which can result in a leak. The other types of problems are usually due to a slower, bigger pump and or fans, which means inferior performance. Weak fans can be replaced with strong ones, but there is no way to replace the pump without some surgery. What is a custom loop, you ask? It's basically the same thing as a AIO, except either you and or an expert designs it, purchases all the parts, and installs it. A custom loop can be much more elaborate than an AIO, with multiple radiators, reservoirs, decorative colors in the liquid, anti-corrosive and biocidal agents in the water, LEDs, and whatever else you can think up. Generally speaking, unless you have lots of odds and ends lying about and are clever at innovating from things not made specifically for custom loops, buying parts made specifically for custom loops will cost you well over $500 for a custom loop and can go into the thousands of dollars. Things you might be able to use include clean radiators from vehicles and other devices where you can drain the radiator and put liquid into it with anti-corrosive and biocidal agents in it. Plastic, glass, or metal tubing of a consistent size that is clean. Containers made of glass, plastic, or metal that you can clean, cap, and seal with a rubber gasket to prevent leakage. Rubber gaskets to make seal-proof non-permanent connections. Silicone, solder, welding, or plastic glue for permanent connections. Plastic or metal barbed nipples to connect rubber tubes to, water inlets. Yes. They're barbed, usually. Compression fittings, elbows, etc. for hardline tubes, valves or taps to drain and or fill or to release air built up in the loop, an aquarium, pond, or other water pump, and decorative pieces of whatever you want to use to decorate it, and so on. And I would recommend looking at Snackson's channel here on YouTube. She did some really interesting builds where she did some custom work on various components of her build to make it look really special, and it's just, her skills are impressive. I've seen a loop made of copper tubing, so use your imagination and skills if you like. Just try to avoid using more than one kind of metal to prevent corrosion. Using more than one kind of metal will cause corrosion, so using one kind of metal through the whole thing will prevent it. And don't mix gallium alloys with aluminum, as the former melts the latter. They don't have to touch to corrode. All it takes is the liquid transporting molecules around. Question: do you need a water or an air cooler? Or should I say, do you need a water or an air cooler? First of all, most people probably do not need a custom loop. It's really only important for people who push their computers to the absolute limit. And not that many need an AIO, unless one or more of the points below apply to you. If the following points don't apply to you, seek out an air cooler that is good enough or better than what your CPU needs. They can last for decades and are less expensive, usually. You will have to consider the space available in your case, including components around your CPU socket and lack of space around the CPU due to your RAM, VRM, heat sinks, capacitors, etc., or if you don't want your cooler overhanging components like your RAM, PCIe, and M2 slots. Both air and water coolers can avoid these issues if you choose carefully. High room ambient temperature will make it hard for both air and water cooling systems to keep your PC cooler. Not PC cooler, but PC cooler, your personal computer cooler. Keep it not as hot, But water coolers will be more effective overall than air coolers because the water and radiator offer more mass to contain the heat than an air cooler's heatsink does, unless the water cooler has a bad design or is too small. Therefore, because there's more mass, there's more ways or more space for the heat to be blown away, so to speak, by the fans. Not really blown away, but the air goes through the heat sink or the radiator And as it does so, temperature agreement, I guess you could say, occurs where both change temperatures. Question: what reasons are there for choosing a water cooler? Here are several of the reasons you might need to, or want to, choose an AIO instead of an air cooler. Remember, most people do not need an AIO, but manufacturers will be delighted if you buy them. They cost more, and some companies price gouge. A very hot CPU, such as the new AMD CPUs that ramp up to 95 degrees Celsius as they push for maximum performance, or Intel CPUs from the 12th to 14th generation i7 and i9 series, especially if they have the -K, -S, or -KS suffix. Even if it's supposed to get to 95 degrees Celsius, cooling it will still give you more performance. Most other components will not overheat except the GPU, unless you're overclocking your system. Keep in mind that undervolting your CPU can help control the temperature with very little loss of performance, and you can do the same with a GPU. Number 2, very intense work. You are doing work that demands high performance and thus heats up your CPU to the point where the CPU is throttling because it's overheating, and generally that means that damage may occur over time. This can include AI work, 3D rendering, videography, CAD, graphic design, AAA games, data crunching, etc. An overheating CPU can result in it becoming warped, which you can prevent and even repair by using a bend correction frame, or BCF, unless the damage is too severe. This BCF can be used with either an air or water cooler. Number 3, case dimensions make it difficult. Your case cannot contain an appropriately sized air cooler. Number 4, case with a poor airflow. With poor. Your case is making the interior too hot due to the case impeding the airflow. High pressure fans, air channels or ducts, a different fan configuration, optimizing the fan curves, and undervolting the CPU might help, and the GPU if you want. And make sure to remove dust filters at exhaust points to improve airflow, and routinely remove dust and pet fur from the ones that you haven't taken off your case. If you don't have any pets, but you find fur, that's a sign of Mother Nature moving in. Squeak, squeak. Some cases are actually designed for water cooling, so they don't work as well for air cooling, and vice versa. Number 5, clearance and impeded airflow or water flow. Components and how they prevent you from using an air cooler of sufficiently high thermal heat dissipation. Number 6, high room temperature and or humidity. The higher the temperature, the less of a range for lowering the temperature is available. Humidity isn't as big of a factor, but it can affect fan performance as increasing humidity thickens the air and the pressure that is required. This is the most difficult challenge to overcome, the heat that is, without an air conditioner or a cool space to keep your PC. Number 7, mysterious overheating. Your computer routinely thermal throttles for other reasons that you don't understand. You could try replacing the current thermal compound or getting a better TIM installing air ducts, undervolting the CPU, and so on, or maybe you need to dust off the heatsink. Number 8, a top-end air cooler can't handle the heat. You have an air cooler that is one of the best, but it's not able to keep your CPU cool. Number 9, CPU cooling plus. You need an AIO that can also cool off other nearby components, such as the VRM heat sinks, M.2 SSD, PCIe slot, capacitors, and RAM. Number 10. You are very sensitive to noise and need something quieter. Not all AIOs are particularly quiet, but they are generally not as loud as a large air cooler. If you're not actually sensitive, try teaching yourself to ignore the noise and adjust your fan curves. With patience, you will get control of your brain. Question: can you tell me more about noise? Are you sensitive to noise? Those on the autism spectrum find it impossible to filter out sensory input, including noise, and some people are sensitive to certain noise frequencies, whether or not they're on the spectrum. Some fans and pumps are rather noisy. Some fans produce harmonic resonances, a tone produced when the RPM reaches a specific speed. It can be something that occurs once at a certain speed, or it can happen at multiple speeds in the range of a fan, which for some people is really annoying. Some fans emit other types of noises, such as rubbing, grinding, which is bad, high-pitched whine, a constant hum except at very low speeds, tones that can vary on the sound spectrum depending on the fan speed, and so on. Some of those noises are normal, and some indicate there's a problem with the fan. Usually, it's going to be the bearing or the motor, unless one of your fan blades flies off suddenly and tries to impale you, in which case you should probably check and see if you're on an assassination hit list. Just kidding. That would be a horribly clumsy way to try and kill someone. The bearings of both fans and pumps play a role in how noisy they are, but water pumps are generally quite quiet. A water pump may actually use an impeller powered by electromagnetism, which is much quieter. I would show you if I had one, but just imagine a little white barrel, and sticking out the bottom is a nubbins, and out the top it's got like little propeller kind of thing, kind of like what a torpedo would look like, or an aerial bomb dropped from an airplane, but with more of those blades around it, and then there's a little bit more above that. So some fans start out quiet when new, but become noisier as they age, especially if you buy one with a rifle bearing or a sleeve bearing or something similar. Some pumps make noises too, including clunks, grinding, gurgling, and so on. Really, though, a pump should be quiet unless it's poorly made, uses cheap material for the impeller and or motor, or there is debris or air in the loop. Clunks and grinding are a bad sign. Gurgling usually indicates that there's air building up in that area. If you're hearing odd sounds and your cooler's under warranty, don't go to a forum. Contact the vendor or manufacturer to request a return merchandise authorization, or RMA, to get a replacement sent to you. Comparing air to water coolers, air coolers are generally going to be louder when the thermal dissipation mass and rotational speed of both are equal. I mean, both as in an air and water cooler, which is to say that they have the same mass to store heat and the same ability to transmit heat into the air or water. And yet, the water cooler will generally be quieter. Comparing small fans to large ones at the same speed, smaller almost always means louder. But there are ways to trade off some of the noise in order to get more performance, and so on and so forth, or lose performance even. Pumps are best off run at the same speed all the time, but fans should be controlled with a fan curve if they are 3 or 4 pin fans. You can set the fan curve such that most of the time the fan won't make a lot of noise, and when the CPU gets really hot is the only time when they move fast and get noisy. Now, on the flip side, if you're not concerned about the pump eventually dying, which it will no matter what you do, although maintenance can definitely make a difference in how long it'll last, you could just opt for a variable fan curve, in which case you'll save money on electricity. So, is the short-term cost of buying a new pump or water cooler more important to you, or is the long-term cost of the electricity spent on a constant speed for the pump more important to you? What do you mean by air channels and ducts, you asked? I thought I heard you say that. These are air paths or tunnels that you can create with poster board, cardboard, metal, 3D printed plastic, aluminum cans, and so on, to force air to go directly from outside your case via a fan to the hot component and then directly out again. It is much easier to design one from materials like poster board, cardboard, or even a product's box, as it's easier to correct them. And no, they will not burn unless your PC reaches over 425 degrees Fahrenheit or 218.333333333 degrees Celsius. If those materials do, it's because your computer was already burning or melting down, so don't worry about it. These ducts should not take up the entire width of the case because you need for the airflow from the other fans to continue to cool everything else, but they should match at least the propeller dimensions, the fan propeller, or be slightly larger because you don't have an airplane propeller in your computer. A smaller size can be used to increase pressure, but you'll need to have higher pressure fans for that. And that may be an excellent choice, but it does come at a cost of more noise. Question: which size AIO should I buy? Well, based on various reviewers as well as feedback from Silverstone, it does depend somewhat. 120 and 140 millimeter AIOs are generally not useful unless you have a very small case and no other options. They are almost always weaker than the better air coolers, except stock air coolers that ship with a CPU, lower end coolers, and some mid-level coolers. Think of them more as novelties and for really small PCs. This does not mean they have no use. They just have a niche market, or niche if you want to be more French about it. 240 and 280 millimeter AIOs are generally going to fit most cases and are often better price to performance. A 280 should always beat a 240 and can sometimes outperform a 360 from the same product line because although it only has two fans, they are 140 millimeter fans, which means they move more air with less electricity and noise. 360 and 420 AIOs are only usable in large cases unless you modify the case and install the radiator externally to maximize heat dissipation from the radiator. They are the most expensive and, for 420s, the least often made by many manufacturers. Unless you really need the extra cooling of a 420, they are not worth it. 420s have 140 millimeter fans just like the 280s, so they will almost always defeat a 360 from the same product line. In summary, a 280 is the ideal size for most users as long as your case can hold a 280 instead of a 240. It is often less expensive than a 360 millimeter and 420 millimeter water cooler as well, and is more likely to fit into the case you have. I'm repeating myself. Sorry. Here are some questions you should answer. Most of these questions also apply to air cooler selection. What is the maximum size for your case? What's the largest AIO size that your case can hold according to the specs? Sometimes what's officially listed doesn't cover all the possibilities, so remember that AIO sizes are based on the fan size, and the sizes for AIOs are almost always one or more of these: 120, 140, 240, 280, 360, and 420 millimeters. You'll also need to look at the overall dimensions of the rad. If the manufacturer doesn't provide them, try contacting them to find out. If that doesn't work, you can try asking on any of the famous IT support forums like, Bleeping Computer. Caution. Some manufacturers do not list the overall dimensions, so you may need to do some mathematics, especially for the overall thickness of the radiator, by adding together the thickness of the radiator and fan. Or, conversely, if it gives you the overall dimensions and you want to know the thickness of the radiator, because that is important to know, then you subtract the thickness of the fans from the overall thickness of the device. Space constraints around the CPU. Are there any space limitations around the CPU socket where the water block or the tubes might not fit? It's not likely unless your motherboard and case are small, but it's possible. Tubes coming out of the block. Will you be able to mount the water block with the tubes entering the side or top of it? Downward facing tubes usually result in air building up in the block, which is bad unless the pump is strong enough to keep the water moving through the system and thus the air. Placement possibilities. Which locations are available for the radiator? Top. Be careful about radiators with the pump inside. Make sure that the water flow and pump are through the bottom half of the radiator, otherwise you cannot install it there. On top. This is especially risky if the pump is mounted on the end where the tube connections are. Front. Make sure the tubes will be long enough to reach that space. especially if you have a long graphics card. If the pump is at the end of the radiator where the tube connections are, you must be able to mount it with the tube connections at the bottom of the radiator. Also, make sure that the tube-mounted pump is not level with the top end of the radiator or the air might get stuck there. Side, same as front. Only possible if there is a side mount port or if you can modify your case, because it is absent on many non-terrarium cases. I call them terrarium cases for a reason. They tend to get hotter than some of the other cases. Bottom, the pump cannot be in the water block, and you must be able to mount the block tubes up. If the pump is powerful, then mounting the block with the tubes to the side is also fine. This will prevent the buildup of air in the block. Exposing the cold plate to too much air will eventually cause your PC to overheat and shut down and could cause damage to your pump. Outside. What? Outside? No, not outside your house, although a custom loop you can do. Some people do that. Some cases are designed in such a way that, by accident or design, you might be able to mount the rad outside the case by passing it through the fan or AIO mounting ports. This will likely require at least some clever modifying if the ports are circular instead of going like this. But it can also provide the best temperature results and give you more space if needed for fans. So it is the ideal solution, even if it does look a bit odd. Space constraints around the radiator. Now, have you measured? Are there any space limitations around where you have to put the radiator? Sometimes a thicker rad can make it very difficult to install it in certain places, depending on the available space in the case and nearby objects like fans. Also, radiators are not usually going to be the same length as the total of the fans and even the same width as the fans, or even. Tube length. How far from the block will the connections on the radiator be? Make sure to remember that tubes bend somewhat, but cannot be forced into a sharp bend without consequences, damage, leaking, decreased flow, etc. Use a flexible tape measure to estimate how long the tubes must be. TDP. What's the TDP of the CPU? Find a cooler that equals or exceeds it. AMD generally does better with a cooler that is designed for their offset chiplets in the newer CPUs, which may require an offset mount to replace the included ILM or mounting bracket on the motherboard. Using this mount may void the warranty, however. Intel. Intel's hottest CPUs with the side flap design, like on LGA 1700 socket i7 and i9 12th to 14th generation CPUs, try saying that 5 times fast, will require a bend correction frame, or BCF, mount to replace the included ILM, or mounting bracket, on the motherboard. This is to minimize warping when very hot and also the pumping out of the thermal compound, and it may correct your CPU if it has already become warped. Using this frame may void the warranty. Overheating components around the CPU. Are you having trouble with other components near the CPU overheating? If so, you need to consider one with a VRM fan, such as the Arctic Liquid Freezer 2 or 3 series, the Evermax LickFlow Max series, such as this SR that has the VRM fan there on the water block, the Asus ROG Realm of Gamers series, although I cannot, because of repeated problems with Asus behaving in illegal and unethical ways and also causing damage to components and then trying to charge customers for them. The Silverstone Ice Mist series, which you can add VRM fans to, and others. Note of these, the only one that isn't sold with the VRM fan is the Ice Mist, as I just said, which offers them as an add-on to the block that you can attach. And you can attach more than one and rotate them around the block to orient them to blow at whatever parts need cooling, unlike all the other VRM fans, which are in a fixed position. Unfortunately, the connector is fairly thick, so the more you need, the wider your case must be. Also, try using air channels to direct airflow over those hot spots instead. Are you willing to maintain your closed loop so that you can use it for potentially many more years? If so, you will need access to distilled sterile water, antifreeze or another liquid with anti-corrosive properties, biocide, liquid or silver, a bucket, flexible tubing, and pipe brushes of the correct size. These will allow you to do a flush and fill as long as there is a port for that purpose on your AIO. Note, if you see fungus or algae anywhere inside, then the biocide is not doing its job. Carefully scrub, especially if it's acrylic, it all off, flush and fill it several times to remove any biofilm, and then refill it with distilled water, anti-corrosive, and a biocidal liquid or anchored piece of silver. For advanced users, you may actually be able to disassemble the water block to gain access to the pump and clean or repair it, but the beginners probably would want to wait until it's on its last legs before they consider doing that. Question: what are other considerations when choosing a water cooler? Fan speed, static pressure, and airflow. Higher is better and gives you more flexibility and improved performance overall, even if you limit its max speed. Setting them to a normal or quiet fan curve will reduce noise at the cost of performance. Setting them to turbo or maximum will improve performance but make your PC noisier. If you can get an AIO with a great radiator, pump, and tubing, but weak fans, go for it. Replace those fans with something powerful. Pump, speed, water flow, and lift. I should say pump speed, not pump, pause, speed. Again, higher is better. A high flow will be more likely to push air out of places where it's trapped, and since it's moving the water more often through the rad, you'll get more rapid cooling. The AIO I currently use has 5,300 RPMs, 1,600 milliliters per minute, and 1.6 meters of lift or head, and is very effective at keeping my CPU cool. And no, there's no head inside, and we're not talking about the other thing either. The third point is where the pump is located. Now, this may sound a little bit repetitive, but it's from a slightly different point of view. For the following, be careful to protect the water block from filling with air. Radiator fin array, where the pump is located in the middle. Make sure it's located in the bottom half, not the top half, the bottom half, the long and wide side facing into the PC of the radiator, or else you cannot safely mount it on top. If you choose to ignore this and enough air gets into the pump for long enough time, it will overheat, dry up, or seize, and unsurprisingly, perhaps, die. In that case, you'll have to mount it anywhere else. Radiator end, where the tubes are usually, if it is located on the end of the radiator, the same rule applies as on top. Too much air accumulated in that area will cause the pump to dry out and die. If you cannot prevent that, mount the rad somewhere else and turn the radiator over so that the tubes are at the bottom. When I say that, I mean that you have it mounted on the side or the front. Now, if you mount it on the bottom, that is another thing that you can do, in which case the tubes will be coming out of the top of the radiator. Pump on the block or in the block. This is the most common, but not an ideal place because it's exposed to the hottest temperatures, which can cause the pump to die sooner. It also means that you cannot safely mount the radiator on the bottom because air rises to the top of the loop and the block will be above 95% or more of the loop. Some people prefer the pump to be here, including some manufacturers, but if the block gets too dry and the pump isn't located where it won't also get dry, then your pump will die. Oh, sorry. Otherwise, the cold plate will get too hot and then the CPU will overheat and the PC will turn off. And finally, on the tubes. This possibly is the best location, in my opinion anyways. Make sure, if you mount the radiator tubes up, that the pump is not as high as the top of the pump inlets or higher, or else air will accumulate there and the pump will die. Now, the next is the cost of electricity, especially if you're on a budget and or the price is high where you live. Do you want to pay that much? Are the LED lights on independent power cables from the pump and fans? If they're not, they're stealing power from the pump or fan. Do the cables use standard connectors, less common ones, or custom ones? The latter will present challenges if you want to expand or combine things, especially if you want to synchronize and color match LEDs. You're much more likely to have problems with LED connectors than fan and pump power connectors. Does it come with thermal compound? If yet, is it pre-applied or an older version? If yes, what is the rating in watts per meter Kelvin? That's not right. Millikelvin. Z. Higher is better. If no, then you can feel free to find a great Tim. No, not a great Timothy. A great Tim. Thermal interface material. Forget it. Does it support your CPU? What I mean by this is whether they include a mounting kit for your CPU. If not, you can contact the manufacturer and ask if they offer or sell a mounting kit for your CPU, even if it's not listed. They might. Is it easy to install? These days, most water coolers are very easy to install, but some people get very nervous. Some coolers give you more work to do than others, perhaps including installing fan corner cushions, installing the fans on the radiator, or the instructions may be poor or even missing. You can use either thermal paste, grease, or pads unless the instructions tell you there's something you can't use. If you're very careful, you can also use liquid metal, but do not let it touch any aluminum or aluminium, and don't use too much so it won't spill onto nearby components and damage them. Question: is it better to get a bespoke water cooling system? Generally speaking, no. Although a custom loop can be readily, if not easily, maintained, it also comes with greater risks than a pre-built and will usually cost a lot more to build, unless you are clever about creating such things yourself. If you are artistic and handy with tools and design, it is nice, but not required. If you can design a loop that is highly functional and can afford such an effort, you also need to consider the risks very, very carefully. Is it okay to buy a used AIO or custom loop? Unless you know the seller well and you're knowledgeable enough to verify the condition of it, including doing a test, buying a used AIO is not recommended, unless you can use it for spare parts, I suppose. It is far easier to repair and maintain a custom loop if you are able to do so, but it comes with all the usual risks, plus those caused by age. If the tubing or a rubber gasket is discolored or stained, less flexible than it should be, cracked, crackled, or otherwise damaged, or shows other signs of advanced age, throw it away. Make sure to have an alarm to warn you if the pump fails you. Check the fans to make sure they rev up to the maximum RPM within a minute or two, preferably within about 5 seconds. Inspect all other parts for indications of problems too. Another major problem is that a custom loop is designed for someone else's system, so the chances are strong that only some of the tubing will be usable anyways due to differences between your PC. If it's a hardline loop, that will require a lot of work for someone to repair the tubing and install it on your system. And softline loop is going to be a lot easier. When you are doubtful or if you cannot test it first, buy new. So really, if you're buying it cheaply to get the valuable parts in the system, that might work out okay, but don't be surprised if you end up with additional challenges. Question: is a VRM fan important? Well, that depends on how much and how often you really stress your PC with high, say 90 Celsius or greater temperatures. If you tend to do very little other than basic work and play, it isn't important. If you're often making your PC hot, greater than 90 degrees Celsius again, or whatever is listed for your CPU or GPU or whatever, having a VRM fan will likely improve the longevity of your system, but probably not improve the overall performance. Question: how do I install a water cooler? Now, this is going to be kind of advanced, and I'm not going to show you a video here of doing that because I think I've already got a video of me installing a water cooler. But You can always look for a video online if I forgot to put my video up. And I'll get it up eventually if you can just remind me in the comments if I haven't, or if you can't find it. So the following are general instructions. Some pre-builts have special instructions that you must follow to avoid trouble, such as installing a BCF or offset mount. Number 1, take a deep breath. It's a lot easier than you think. I mean, not just the breathing, but putting a water cooler in there, not a custom one, but a pre-built one. Number 2, attach the fans. If they aren't attached, attach them with the provided bolts to the radiator. The simple rule for mounting that's something like that, block, fan, radiator, etc., is to loosely screw in the first bolt or nut, then do the one opposite that, and then the one opposite that in a star-shaped pattern, just like when you put the lug nuts back on your vehicle's tire until all bolts are in. Do not screw them in all the way the first time, as this can result in a misaligned install. For example, repeat this pattern that I'm going to show you until they are tight, but you're not damaging the corners. So for the purposes of this demonstration, I'm going to use this fan frame that I use for testing. You're going to tighten up one part way, and then do the one opposite, and then you do this one or this one, and then you do the last one. Then you go back to the first one, tighten it up so it's almost fully tightened, and then this one is almost fully tightened, and then this one is almost fully tightened, and this one's almost fully tightened, and then go back again, because sometimes by doing it in this way, you will release some misaligned bolt or whatever so that there is further slack available. And you may find that even twice more, you've already tightened up everything, and then you find out that, oh, I didn't, because some pressure got released, so something else is now loose. Do not over tighten. Let me say that again. Do not over tighten, and be careful not to misthread the bolts, as this can damage the hole and make it useless. The bolts are most often called screws, and they may be found in a separate small box or bag, possibly with the mounting kit. You might find that there are even 2 types of rad bolts. Some companies use non-standard bolt length and radius, especially for the rad. There are other sizes, but the following are fairly common. Fan bolts are short, about 1/4 to 3/8 of an inch or 1 centimeter, and they may be slightly tapered at the end with quite deep threading, like these, which means they are self-tapping, so they'll create the threads in the plastic of the fan frame as they're screwed in. If it's not self-tapping, it's most often they just didn't want to do it, or the holes are already tapped, or the holes are made of metal, in which case you can't self-tap them with a fan bolt or screw. These are to mount the radiator against the case, in the case of one that is not a self-tapping bolt or screw. Radiator bolts are longer, about 1/4 to 1 3/8 of an inch or 3 to 3 3/4 centimeters, and only have threading near the end. These are for mounting the fans to the radiator. Radiator plus halos bolts. Now, what it means by halos is something else, and I don't have any information to share with you about that, but these are going to be longer than this kind, about 1.5 inches or a little bit more than 3 3/4 centimeters, along with threads near the end also. These can be used to mount the fans to the radiator, but are longer, so you can mount the fans to the radiator and the case at the same time. In other words, you put the fans between the case and the radiator, and then you run this longer screw through so that it properly and firmly secures the radiator to the case with the fans sandwiched in between, in a very loving relationship in which there's no abuse, I hope. Mounting kit. Some people prefer to mount the radiator first, but most start with the water block. If you're inexperienced or you've noticed the tubes are barely long enough, I would definitely start with the block, as it involves much more than the rad, and you don't want anything making the installation more difficult or, worse yet, messing it up. You'll have an easier time doing this if you can easily stand up and lay down the case. Standing up to install the back end, once it's affixed, lay down the case and finish installing the block. If the back plate isn't retained, use some double tape, regular tape, or a piece of cardboard to help keep the bolts from slipping out of the holes as you lay it down. Take out all of the mounting kit pieces you need for your CPU and store the rest. You never know what your next CPU will be. Again, if you have an AMD AM4 or AM5, then the motherboard already has a backplate, so one won't be provided for those two types of AMD CPUs. Backplate. You'll need, this is step 4, by the way, I kind of lost track of my numbers. You'll need to put the mounting plate on the back of your motherboard if it's an older AMD or if it's an Intel. There may be spacers or other parts to use with or after that, maybe even double tape to hold the back plate there as you lay it down. So the front plate for an AMD CPU for the AM5 or AM4 might look something like this, and there won't be a back plate because one's already installed on the motherboard. You may have spacers like this, which are just plastic spacers that are usually blue for Intel. You may have double-sided bolts like these. You may have single-sided bolts. You may have other things. It just depends on how the manufacturer decided to do it. Number 5. TIM. Remove the clear plastic protective barrier on the cold plate. Apply the thermal compound. Some people prefer to apply it first, but I hate getting it on my knuckles and fingertips as I'm screwing things in and tightening stuff down. There are lots of ways to do it, but unless you notice something really wrong with the cold plate, in which case you return it, you can try 5 dots, NX, 3 parallel lines running along the length, or you can smooth it out over the whole thing just like peanut butter as easily as possible with a plastic spreader of some kind. If you're using a TIM that isn't electrically conductive, it's okay if you add a bit too much, but it's not okay to be stingy. A little mess is better than bare spots. One pea-sized dot is not ideal for a large CPU as it might not spread all the way to the edges and corners of the CPU. If you're working with liquid metal, please be very careful not to let it slop over the edges of the CPU onto anything else, both because of the gallium in it that can melt aluminum and also because it is electrically conductive and can short circuit something nearby. Number 6, mounting the block. Make sure that the tubes will be pointing up or to the side, and that in that position, the tubes will allow you to mount the radiator where you plan to put it. If the tubes are on the side of the block, make sure that if they are not located in the center of the edge, then try to make sure that they are on the side that will allow them to be closer to the top of the case. Please allow me to demonstrate. If it's mounted like this with the tubes at the top, good. If it's mounted like this with the tubes at the side, also good. If the tubes are like this, where they're coming out the bottom, that is generally bad. Now, if you have tubes that are not located like this, where they're very, very much symmetrically located, say, for example, you've got the tubes up on this side, then you want to have this like this, but not like this, where the two tubes are coming out down here. That can lead to air being stuck up in this side. Align the holes with the bolts after you've added any other hardware for mounting the block, and make sure that nothing misses the target as you lower the block. It really sucks when you do. There will probably be some wiggle room for mounting the block, so try your best to center it. Hold it in place and grab the nut or whatever you need to secure it. And when I say nut, I am not referring to the food or your crazy best friend or those other things that I will not explain. Step 7, screwing it down. Following the same process as for the fans, number 2 above, gently above. Yeah, look up. Gently but firmly hold the block against the IHS, or the hot plate of the CPU, and repeat the pattern until each bolt gives you a bit more resistance. Again, if you're not remembering what I explained already, you gently but firmly hold the block and the CPU together, and then you partially tighten, 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 tighten. Following that pattern, again with the screwdriver, once you've got it finger tight until you get firm resistance with each nut or bolt, then stop turning. Do not over tighten. You don't want to crack your motherboard. Once each nut or bolt is firmly attached and you're sure that no slack has been released somehow, we're halfway there. Number 6. Position the... Number 6. Now that's not right. Yes, sorry about that. Sometimes word processors have a problem with numbers. That's because they're word processors, not number processors. Position the radiator. Number 8. If you didn't already attach the fans, you can do so now. Being careful not to pull the tubes more than gently, gently move the rad to where you plan to mount it. If the tubes are flexible but not impervious to damage, the tubes are inflexible but not impervious to damage or dislocation. So don't try to fold them or force them to tightly wrap around something, resulting in too much strain at the block or rad. If you're having some difficulty and the tubes can be mounted differently to avoid stress and provide more slack, especially if the tubes have rotating elbows at the block and or the rad, take advantage of this to help reach the mounting position. If you cannot hold it in the position you want without forcing it, you may cause damage by mounting it there. Evaluate carefully, and you may have to reconsider the location, which can be really annoying. Number 9, attach the rad. I find it easier to loosely screw in a bolt at the top than one in the opposite corner at the bottom, which usually makes it easier to keep the rest of the holes aligned. And just like the fans and block, number 2 and number 7 previously, follow the X pattern to attach and then tighten down the rad. Remember, X marks the spot. Be careful not to strip the bolt holes, as the metal is weaker than the bolts. Number 10, connect the cables. There should be 2 to 3 kinds of cables: the fan cable, the pump cable, and the LED cables. So LED cables, most ARGB cables can be daisy chained and then plugged into a single header on a hub, controller, or header. There are probably some out there that have just RGB instead of ARGB, and those can also be daisy chained. I think that LEDs are stupid and a waste of electricity, even if they're not vampirizing power, because they run off the same cable as the fan itself, so I don't plug them in. Several companies have opted to use non-standard connectors, which may require that you buy only certain splitters, hubs, and controllers, netting them more money, especially if they don't provide the splitter option. Another reason to avoid LEDs. Pump cable. The pump will almost always have a 2 or 3 pin connector. Don't connect it to the same header that's controlled by a curve for fans that are also attached. If there is a pump failure alarm for the pump header, use that on the header in question and turn it on in BIOS. If there isn't one, you can accept that if the pump fails and the CPU overheats, the PC will shut itself off to protect itself, or you can plug it into the CPU fan header instead, which usually has that alarm. If it doesn't have an alarm either, don't bother. Honestly, unless electricity is super cheap where you live, calculate whether it's going to be cheaper to have it on a variable curve versus the cost of replacing it when the pump dies, or if it'll be cheaper to, so basically, if a constant speed resulting in pump failure sooner, and then you have to buy a new AIO, is going to be more expensive than the ongoing savings of having the pump on a variable curve, but the pump doesn't last as long. And finally, the fan cables. The fans will almost certainly have 3 or 4 pin connectors, and depending on how much amperage it uses, you may need a hub or controller. Most motherboard headers provide up to 1 amp. Anything more could potentially damage the header. You may be able to daisy chain them with a splitter if the total amperage is less than or equal to 1 amp, or a PSU powered hub or controller. Hopefully, the manufacturer was smart enough to have the fan cables chained together. Number 11, BIOS settings. You'll need to go into BIOS to make sure everything is configured correctly and to your satisfaction for the pump, fans, and LEDs. Pump. If you connect the pump cable to the CPU header, make sure that you switch it to DC in BIOS and or set it to a constant speed. I recommend somewhere between 70 to 100% to reduce wear on the pump. However, if the cost of electricity is very high or you love the environment, you may want to set a variable curve instead to decrease power consumption. The downside is that a variable curve will cause the pump to wear out faster, but hey, if you're saving $50 a month and the AIO costs you $20 and lasts 4 years, you've just saved thousands of dollars. If you decide to use the pump header, make sure that the BIOS setting matches the fans connected, which could be DC or PWM, and set a variable fan curve. Fan. Make sure that the headers are set to PWM for a 4-pin or DC for a 3-pin or 2-pin, and then either choose a preset fan curve or make a custom one if your BIOS allows it. Run your OS and do something very demanding to see if the noise will be unacceptable. Then return to BIOS to optimize. In some BIOS, you can actually test this from within BIOS by establishing a high minimum that is triggered at a low temperature, and then adjust up and down to find the threshold where the noise is too much for you. With that knowledge, you can then customize the loop, making sure that the fans only reach that threshold when the CPU is very hot. And LEDs. Before loading up your OS, make sure that your BIOS is set to have the ARGB or ARGB system active. If you don't want the lights, the best thing is don't plug in the ARGB or RGB cables in the first place, or deactivate the lighting system entirely. Question: how can I maximize cooling for both my CPU and GPU? While there is sometimes an ideal position to provide a balance, and in my testing it was on the side, an AIO is designed for the CPU, so get an air cooler. Add air ducts to direct fresh air to each component and then directly out of the case while allowing airflow around the ducts. Optimize your fan curves. Underbolt both your CPU and GPU. I'd like to thank Grindler at Bleeping Computer for allowing me to share my videos and posts on his website. Bleeping Computer has a lot of resources, including vetted programs, malware removal instructions, malware removal volunteers, other kinds of volunteers for IT, cybersecurity information, and more. It's a great place to go. Give it a try. Thanks for watching, and I hope you have a great day.